Okay, so I'm going to get in here, and what I want to do is just show you a little bit of SQL. Oh yeah, that would really help, wouldn't it? So eventually that'll come up. We could do this in the dark, you know, you could kind of imagine what I'm doing. So I have a script that I did for Python Club, and I don't want it to replace yours. But if you really wanted to follow along with it, because I'm going to do my queries in that because I don't have another thing to do it from. If we go to GitHub, so I'm going to do github.com spconger. And if you go to database schema, and if you go to other scripts, because I was trying to hide it from you a little bit, there's Python Club SQL. What I would do with this, though, is make it like Python Club. So I would download it as a, go to raw, and I'm going to Control A, Control C, put it in a query window. But what I would do right at the top is, it's actually a little bit of a pain because you have to change it in a lot of different places. But I would change the name. So
like refactor it, so it just changes it.
Yeah, I think can we do this with if we do shoot, my mouse just died. I was going to see if I could, you know, do the find and change.
Oh, in the in the other window.
Or in this window, yeah. Whoa. Okay, now my mouse is back.
Well, could you put it in a Word document and do it that way?
You could do it. I wouldn't do it Word. You could do it in Notepad. I'm wondering if there's a find and change here. If not, all right, so I'm going to copy it again. Control A, Control C. I'll put it in Notepad. Anybody know why I don't want to put it in Word? Whoa. That's a bit of a pain, though. Let's see. Don't save. Let's try WordPad. What I don't want are curly quotes. So if I paste it into there, it should come through. Hopefully it's not replacing. We want it just as text. But what I want to do is find and replace. So there's find. And I want to find Python Club. Oh, actually replaces the next one. I don't want to just find it. I want to replace it. Python Club. And we want to replace it with Python Club. What do you want to say? B, A, other? Python Club B. So I'm going to replace all, which may be a mistake. But I went through, and so it should be everything is Python Club B. And I'll go through this process again. It's not super important, but I'll bring it to do. I'm going to do Control A, Control C. I'm going to close this query and do a new one and paste. And it should the classes should be Python Club B. So when I run this, I actually think I have to select it all, do I? No, maybe not. Did it work? I don't think I ran it actually. I think I have to select. No, there's Python Club B. Does it have all the tables? It does. Does it have the data? Let's do member or meeting. Any of them. I just want to see if they have the data. Yes, it seems to have the data. But again, I don't want you to replace yours. So do you want me to go through that whole weird process again? Because kind of I was just doing proof of concept that it would work. Are you guys okay? No comments? Anybody need me to do it again, or are you guys okay? Do it again? Okay. So what I did first, I won't spend a lot of time on it, but I went to spconger database schema, right? So if you go to github.spconger, you come up with this main page, and database schema is right at the top. In the schema, I did other scripts, and there's Python Club SQL. So this is just SQL that I did by basically I took the capture from the forward engineer, and then I just added the inserts. So you want to do raw, partially because it's formatted in there, and when you copy it, you get some of the formatting code, and then it doesn't work. And then you can do, select it all, Control A, Control C. I did WordPad just because it was a little nicer. I'm going to kill this document and do a new one, I guess. So I did just WordPad. It worked better than Notepad. WordPad doesn't put curly cues in there, and there's actually not Word in here anyway. So I pasted it. All right, and then I did replace, and I did Python Club with Python Club B. To run it again, I'll make a Python Club C. I'll replace all. I will copy all the Control A, Control C. Go back to here. I'm going to open up another query. I'll paste this. And I believe if I just run it, it should be fine. And if I do this, refresh, I have Python Club, I have Python Club B, and I have Python Club C. So I have 3 copies of Python Club, which is a bit excessive. One of the nice things about SQL, if you would just want to look at the script sometime, is that you can do that. You can create a database really fast by just, with the script. All right. And if you don't do that, that's fine. And if your database wasn't named Python Club, you didn't have to do the replace, right? If your name was a little bit different, you don't have to. I'm not going to save that script, although you can if you want. I'm just going to close some of these. So I may end up doing some of your assignment for you, which is not my intent, but it's because I don't have the sample database in this one that the other class had. It's a different install. How many of you have Sakila database? I think the way we installed, we didn't get it. Right? In the other class I did install with the sample databases, we didn't get the sample database. So I just have this club. So I am going to just do use Python club. If you want, you can use Python club B. Shall we use B? All right. Semicolon, that's the big difference here. And you can go down at the bottom where it says use by Python club B. If your SQL works, it gives you a little green check mark. If it doesn't work, you'll get a red X.
Did you just go to a new query?
Yes. What I did was I clicked on this SQL thing here, the very first icon. But I think it would be the same if you do a new query. So part of what I want to show you is that nothing that we're going to do is any different from what was in SQL Server. Right? SQL is the same across platforms for the most part, about 90%. You can the stuff that you do in SQL Server will look the same here in MySQL. It'll look the same in Oracle. It'll look the same in whatever you do. So if I want to select like all my locations, I can just do select asterisk from location. Same syntax. The only difference here is that it will complain if you don't do the semicolon. It'll actually run it, but it'll complain. So when I do that, and again, you can select it and run it, you get, this is all my locations. So let's do just real quickly an inner join. I'm going to try to do different inner joins and things than what I asked for in the assignment, but very similar kinds of things. You guys don't seem real excited about all of this, so. But we'll just do a few things, just enough so you can do the finish getting your data in. I know most of you are still working on that. That's fine. And then we'll do a little bit of, this is if you finish your data, you'll have something to do. So let's say we wanted to know what locations the different presentations were in. So notice there's a location.id location. So I'm going to select probably because, so let's take location name, I think is one of them. I got room name. I'm going to do room name, street address, city, and state for those. And then for the presentation, I'll take the presentation date and the topic. I'll just take those three. Notice how I copy them. If you just hold down the shift, you can copy, multi-copy. And it's really nice to be able to drag them in when you are like spelling challenged like I am sometimes. So just like always, we do from one of the tables. So I'm going to do it from location. Can't type, but there it is. And then I'm going to join or inner join. They're the same, right? You can do join or inner join. It doesn't matter. Joins are assumed to be inner joins unless you specify different. So I'm going to join with presentation. And I'm going to do this on, and we have to say how those two tables relate. You don't necessarily have to do the location dot because these are different. So they won't get confused, but I'm going to, so primary key, foreign key. Because these are different, I could just say where ID location equals location ID location. But just to show you where they're coming from, I think that's fine. And if I run that, it shows me I have two presentations. They're both at the same place because I wasn't very imaginative when I was entering data. But it gives me the room name, the street address, city, state, date, and then the time, and then the name of the topic of the presentation. Does that make sense? Sort of. Let's do one more. This one might be in the assignment, but it's a little harder. And again, your structure of your database is probably different than mine, and that's okay. A lot of it, your structure depended on how you interpreted the rules. And so this one is my interpretation, but it's not necessarily the only right one. So I'm going to say how many members attended meetings. So I have meeting attendance, and I have person. And then I have, mine is a little bit weird because I also have, I think members. Members only have, they're related to person. All the people are in person. Right, so a member just has a link to person. So I think I'm going to have to join like 4 tables to figure out who's in what, went to the meetings. And I'll do that just so you can see it. Most of yours would be simpler because you'd put the names in the members, right? So I'm going to, from person, I'm going to take first name. Should have probably just taken both of them. First name, last name. All right. I'm going to, from meeting, I'll just take the meeting date, meeting time and topic. Not going to worry about the location. Okay. So we want to see who attended each of these meetings. I think I'll just, in a moment, I'll do, so I'm going to do from person. And then I'm going to have to do, include member, even though I'm not actually taking any fields directly from member. But the path, the relationship path will go through that. Does that make sense? So I'm going to say join member. Oh, and this should have semicolon. So I'm going to do join member, and I'm going to say how they join on person dot person ID person equals member dot person ID person. So those are primary key, foreign key, how they relate. And then I am going to join to member attendance. Or meeting attendance, rather. So it'll be on meeting, well, let's do a member dot, it's not giving me, is it members? No, it's member. So it's member.id member equals meeting attendance dot member ID member. So those how those two tables relate. And then lastly, I need to join meeting and say how that relates. On meeting dot, which is not giving me IntelliSense. So on meeting dot meeting ID meeting equals meeting attendance dot meeting ID meeting. And then let's just do where meeting or ID meeting. I'm going to just say where it equals 2. We're just going to choose one of the meetings. Does that make sense to you? So we're going from person to member because the person key is a foreign key in member. And then we're going from member to member attendance because we want to take that member key and map it to attendance. And then we go to meeting and we get because the meeting key is also member attendance. So it shows how all those things relate. And if I run this, it gives me all the people who were at that particular meeting, the number meeting number 2. I do. What it does is I said it'll run without a semicolon, but it'll throw the next line will have an error in it. Right, so if I don't do a semicolon and then I go to, see how it's got an X beside it? And then if I do this, it'll be okay. So most of your things will be kind of like this one. A couple of them might be like this. I'm not sure any of them will be quite like that, where 4 joins. Or it's 4 tables. But you see how you could do it, right? You can keep joining them as long as you need to. As long as they have a path, as long as there's a relationship between key and foreign keys. And if it becomes really difficult, you can do this by looking at the model, which I'm not sure I have the model for this, but I could reverse engineer it if I want to look at the model. Okay, so some of these were selects, and then there was some inserts. And inserts are exactly the same as they were in SQL Server. So let's say I wanted to insert a new member. Where for me, this is more complicated than it would be for you. So I'm going to do insert into member. First, I have to insert into person, right? Because all my people are in person. And generally, it's a good idea. So let's find person. So it just has those 3 fields. And then I would do values. And let's give a person a first name. Anybody have a good? I guess I could join. And this isn't a real email, but okay, so I would do this. And then it says basically that it inserted. I don't remember if there's I don't know if there's a function that would let me see what the ID of that is. So I would probably just do, there may be, I just have to look it up. Select star from person. And there should be a semicolon there. That's why that's underlined. I'm not good at remembering. All right, so I am number 11. So to insert into member, so I am going to go to member, and basically it's just person ID and join date. And I'm going to, 11 was mine, and for join date I can do current times It's a timestamp I want, current timestamp. I'm not sure if I use date or date time. Might be that I want current date. It says date. Let's do current date. Okay, and that says that it's okay. So if I select from member, I should be able to see that. So there's 11 is that person, and they gave the current date. How do you find things like current date? One, in IntelliSense, like I just did. The others, you could just go online and look. There's no way to know. The things that differ between different, things are like the function names. Function names are different in different products. But current date is fairly easy to guess. So the point of this is that the inserts are basically the same as what you did before. And you might have to insert into several tables. Does that make sense? To do one thing, to set up a member or whatever. And I think there's only one other thing I want to show you. I have multiples of here, so I can do this without destroying things. But I want to show you how to do an update. And I also want to tell you that an update is the most dangerous, one of the most dangerous commands there is. And in real life, you should probably not give anyone update permissions directly. You should create a stored procedure that handles updates. I'm not going to necessarily show you how to do that because that's a more complex. But I'm going to first make a quick comment here. So updates change existing records. Does that make sense? And this is all underlined because I didn't semicolon. All right. Updates change existing records, where inserts add new records. So you should always have a where clause. With probably the ID, with the key field. Now, SQL not SQL, but Workbench actually has a setting where it'll force you to have the where clause. But in general, most environments do not have that setting. And I'm going to show you how to destroy a table. And then I'll show you how to recover from it. But if you destroy it without doing all the proper steps, there's no recovery. Right? You could lose your job over this if you really didn't know what you were doing. So I'm going to do, first I'm going to do an update properly. And it's the way we do it. So let's look again from person. I'm going to just real quickly select from person. And my first one is John Wright. Let's make him John Wrong. So I'm going to update person. I am going to set, now you shouldn't have to have a semicolon after, I think it's just the set. I'm not done yet. So let's say set last name equals wrong. And I'm going to also do it like a comma here. And we'll say email equals John, oops, single quote, John.wrong @gmail.com. And then I'm going to say where ID person equals 1. Okay, so this is how you do it properly. And I'm going to just run that. Okay, and it says that one, it worked. And then if I run person now, you'll see that it's now John wrong instead of John right. And the email was also changed. So the syntax of this is not hard, right? It's really easy. The dangerous thing is what do you think would happen in most environments if I don't have the where clause? Anybody have a guess?
It would update all of them.
Everybody's last name would be wrong. Everybody. Imagine if there were, 100,000 people in that record table, and they were all suddenly named wrong. So I'm going to do. You have to kind of fudge this to destroy a table here, but because of the environment is protecting you, which, as I said, most environments won't. Semicolon. So I'm going to do something which you can do if you're doing updates. I'm going to do start transaction. Anybody have any idea what that's doing? I'm going to run that. It doesn't do any good to write it and not run it. So we're taking manual control over the transaction. Generally, every single statement is a separate transaction. You don't have, it just runs and then it's done, right? This is actually not a thing you would want to do in a production database because I have just locked the database. And if I go away to lunch, it's going to be locked until I come back. Because I'm manually locking it while I do this. It doesn't matter when you're by yourself like this, but if it was a multi-user database, a lot of people would be pretty PO'd. You can put this in a stored procedure or something, which executes as a single thread, and you can start a transaction, and then if there's an error, there's 2 reactions to transaction. You can roll it back, or you can commit. You can only do one of those, right? I've written them both, but I haven't done. You can only do one of those. If you roll it back, it undoes what you did. This is the only undo there is. Anything else is just done. There's no undoing. Generally, if we didn't do this transaction and we wiped it all out, the only way to fix it would be to restore from backup. Since we have no backups, we'd just be screwed, right? I am going to do this same thing. I'm going to change it a little bit. I guess I'll just write it again. Let me make that a little higher if I can. So I'm going to update person. And I did run the transaction, so it's really important that you do this. Although, we can always recreate the database. So I'm going to set last name equal. This time I'll do it as Smith. And then I'll do, actually that's all I'm going to do is just the last name. This is only because this environment where ID person greater than 0, which is for all of them, it will let me do that, weirdly. So I'm going to run that. And it's happy. But we wouldn't be happy because if I do select star from person, everybody is named Smith. Right? And that can happen pretty easily if you just forget the where clause or have a clause where you accidentally change a bunch of names. Like there are a lot of Smiths. If you were changing somebody's Smith and you just said where their last name was Smith, you might change a lot of people's stuff. So I always think of this as like the last movie of The Matrix. You guys know that one? Where everyone becomes Mr. Smith. Yeah. Oh well. Have to have something, you know. So the thing is, because we're in transaction, what we're actually getting here is more of a temp table. So if I do rollback, and then if I do select start from person again, it's back to the way it was. Yeah. Well, so if you do a start, this is a protection. If you start a transaction, then you can do your thing. You can select from it to test it to see if it's correct. If it's correct, you can do commit. If it's incorrect, you can do rollback. It gives you an undo. For selects, it doesn't matter. I'm suggesting it when you do your update. Yeah. You cannot. Yeah. There's no, if you don't do start transaction, there's no rollback. Right, yeah. And so if you do it, if you make the mistake, like you just type this instead of equal or something, yeah, you're just screwed. I mean, in our case, it's not so bad because we could just run the script again. But start transaction locks the database. It does lock the database. Yeah. So you have to roll back or commit. So commit writes it to the database. Rollback counts as getting out of it. No, you ended transaction with one of these two. No, that's fine. That's good. Good questions.
So if you wanted to test this in like a real database, you would just write it, test it, and execute it with rollback just to see it, and then if you liked it, you can commit it rather than.
You could. The only thing with the real database is, again, is if lots of people are using it, yeah, you're locking it while you do that. Typically, if you're testing, I would always suggest making a copy of the database because you don't want to mess with things. And a lot of times you're going to end up with a lot of garbage data when you're testing things, and you don't want that in your real database. So typically, and even when you're building applications, like I build forms, like in the 172 class for those of you do. So we post through those forms, but we're posting garbage because we just want to see if it's working, right? And you don't want that to happen in a real database, so you need a copy of your database. There is a thing called a stored procedure, which is really a script of SQL, and it executes as a single thread. And one of the things you can do in there is you can start a transaction, go through, and then at the end you can commit it, but you can put it in a try-catch. I don't know if you guys have done programming, but a try lets you try all the code. As soon as there's an error, it throws it to the catch block. And in the catch, you tell it how to handle the errors. And one of the things you can do in the catch block is roll it all back. And the thing with a stored procedure is because it's all a single executable script, it doesn't lock the database for more than a nanosecond or so. So it works much better in that. And I would suggest that if you're ever dealing with giving customers the right to change their own information, you would make a stored procedure to allow them to update it and not give them permissions to update directly. Because you can give them permissions to run a stored procedure without giving them permissions on the table. We might look at that. I think we're going to have time enough. We can spend a little time on permissions and roles and things like that. So this is the only thing that's new in the assignment, is I did ask you to update something, because I think you should see updates. I will show you real quickly how to delete something too. If I wanted to delete me from the database, so I would have trouble, actually even me, I can't delete me from person. I'll show you. I'm going to delete from person, where person or ID person equals 11. Okay, so that's B, it will not let me delete. Does anybody know why? So I will run it. I can't delete from person because there's related to it a foreign key. You cannot delete a parent record that has child records and other tables, right? So because it would leave an orphan, it would leave data that has no connection to anything else, right? So it doesn't allow you. This is what a foreign key does. You cannot remove it without removing the primary key first. The other thing is you can't have anything in the foreign key child table that doesn't exist in the parent table, right? There's two sides of the same thing. So, although it sounds really cruel, you have to remove the child before you can remove the parent. So I would have to, if I go delete from member, where ID person equals 11, from the child table I can do that. Why does it not? It's not case sensitive. What is it not liking about that? Oh, it's not named ID person in the. What is it named in the member? Is that it? Person underscore ID person? Yeah, that's what it would be then. Yeah, there it is. So I could delete this now. So it's happy now. So it's gone from there. And then I can delete this. And see, it's happy to delete the person now that the person has no children. Yeah.
So you're selecting them and then running them, but if you would have got all in one script, you want to put that line that's above, correct?
Yes.
So it runs after.
Right. So I could do, I'll just put it above. Deleting removes records from a table. You can, I don't know if I want to actually run this, but you can drop, if I were to say drop table, actually it wouldn't let me probably drop member. It would have to be a table with no children again. I could, are there any tables with no children? There must be. Presentation probably. I could probably drop presentation. If you do that, again, I'm not suggesting running this. The presentation table would just disappear, and there's no undoing it. Right? It doesn't empty all the records out of the table. It literally deletes the table. So this is how you get rid of objects, is to drop them. Delete gets rid of records. Drop table. And delete's a little dangerous too. If I did a delete from presentation without a where clause, it would remove all the records because they're all child records. So it would remove all the tables, all the records from presentation. So it's a little dangerous too, because you could empty a table pretty easily by forgetting the where clause. I think that's enough of this because I know most of you are still entering data. I just want it, when you're done with the data, there's a few questions like last time for you to run the, some queries. Yeah, I'm going to post it right now. Yeah, I'll put it on the blog. And there's a video also, which I'll post in just a second. And then next week, we'll see where you are, but I think we'll begin talking about NoSQL, which is a whole different world and will confuse you utterly. But it's fun. It's a fun confusion.